So we are discussing about the hydrological cycle. We can define the hydrological cycle as the endless circulation of water between the oceans, atmosphere, and the land. The inflow to the hydrological system arrives as precipitation in the form of rainfall or snowmelt, and the outflow takes place as a stream flow or runoff and as evapotranspiration. This is a combination of the evaporation from open bodies of water evaporation, that is from the soil, and the transpiration from the plants. Precipitation is delivered to streams both on the land surfaces as a overland flow to the tributary channels, and also by the subsurface flow rates as the interflow and the base flow following the infiltration into the soil. So when it comes to the subsurface distribution of the groundwater zonation, we can see the subsurface distribution of groundwater is divided into zone of aeration and zone of saturation. So these are the two zones. In the zone of aeration, which is an unsaturated zone, it could be divided into again three subdivisions. One is zone of soil moisture, intermediate zone, and the capillary fringe. There are no sharp boundaries between these kind of zones. The soil water zone is subjected to large fluctuations of quantity as well as quality in response to the transpiration and the evaporation process. In a normal forest environment, if you take an example, various trees may have some roots which will be extending more than to a depth of 30 feet. So the moisture fluctuations include or by the plants generally diminish until a depth of 30 feet is reached. The moisture in the upper few inches of the soil zones also change owing to the large fluctuations of temperature and also vapor pressure induced by the variations in the air and the groundwater temperatures. An intermediate zone commonly separates the saturated zone from the soil water. The water in the soil zone and the transmitted zone is called as suspended water or Vaduz water. This water is in the downward motion under the influence of gravity. So, if we see here, we can call it as a gravitational water also. The intermediate zone may be absent in the most of the environments, and if you take in the arid zones, it may be more than 1,000 feet thick. If the material in the intermediate zone is an isotropic one, and if the recharge takes place, the moisture content in the intermediate zone will generally range between the near saturation to as low as the specific retention of the material. The intermediate zone terminates below the capillary fringes. The, trans- the transition to the capillary fringe is rather abrupt in coarse grained sediments, but is very gradual in silts and clay. So here if you see the clay, and when come to the porosity, you'll understand the non-porous and permeable, porous and non-permeable, porous and permeable. We'll discuss about that. So if the recharge is active in fine-grained soils, there may be very little difference in the moisture content, which is between the intermediate zone and the capillary fringe. The surface of the capillary fringe is irregular in detail and its position varies constantly with the change in the water level and also on the amount of the recharge. The zone of groundwater is divided from the capillary fringe by a water table. So you can see the water table here and the water table here. Water table is actually a theoretical surface which is approximated by the elevation of the water surfaces in the well, which penetrate only a short distance in the saturated zone. So if you can see on the top, water table you can see. So a more exact definition states that water table is the surface in unconfined material along which the hydrostatic pressure is equal to the atmospheric pressure. We'll discuss about the types of occurrence of groundwater. The water bearing portion is called as aquifer. In this you have three types. The rocks which neither transmit nor store water are called as aquifers. For example, you can take a solid granite. So they cannot store the water and they cannot transport the water. So they have no pore space and they are non-porous and non-permeable. The other type is the rocks which contain some water but are not capable of transmitting the water, and these are called as aquicludes. In this, you have the unconnected pore spaces. They are porous and non-permeable. You can take example of clay. See, you can see the clay here. The unconfined and confined aquifer are separated by the clay. And coming to the third type, rocks which can collect, store, and transmit significant amount of groundwater are known as aquifers. So these are having connected pore spaces. They are porous and they are permeable. That means they can collect, store, and also transmit the groundwater through them. If you take an example, you can have sand or pebbles or any kind of fractured rocks. So let's discuss about the confined and unconfined aquifers. So you can see the confined and unconfined aquifer here. Water that is directly contact vertically with the atmosphere through the open space in a permeable material is called as unconfined aquifer. So you take the example of lakes, rivers, channels and all. They are exposed to the atmosphere. So the water gets evaporated easily from the unconfined aquifer. The confined aquifer is from the atmosphere by the impermeable water. So the confined aquifer is like a closed space. It is not directly exposed to the atmosphere. The division between the confined and the unconfined water is entirely gradational. The term semi-confined is used for the intermediate conditions. That means they are somewhat exposed to the atmosphere and some are not exposed to the atmosphere. So we call this as intermediate condition or intermediate zone. In many areas, the first unconfined water encountered is above the general zone of phreatic water. See, if you take this, you'll understand clearly. This is more or less isolated body of water whose portion is controlled by the surface, structure, and the stratigraphy. So we call it as perched water table. So this is the perched water table. A geological cross section, you can see it here. A confined aquifer sometimes becomes a flowing water, and such system we call it as an artesian system. So you see artesian well here, which is on the artesian systems are quite common in most of the sedimentary basins. So this is about the groundwater cycle and types and occurrence of groundwater, the different zones of groundwater and the unconfined and confined aquifers along with their properties like the porosity, permeability. The next we'll discuss about in detail of the physical properties of an aquifer.